We're going to solve this physics problem, and the problem states a kicker kicks a football at 20 meters a second at a 60-degree angle towards a field goal that is 30 meters away. A helmet is struck at the end of the kick. How far behind the field goal is the helmet? And the second question is, how high above the ground is the ball when it crosses the field goal? So to first start, we want to solve for the range because that is where the helmet will be. So to start, we are going to use this vector here, and we are going to draw a triangle with it. And then we're going to put 20 meters a second here and a 60-degree angle there. So now, because it's a 30, 60, 90 triangle, we know the side opposite the 30-degree angle is going to be 1/2 the hypotenuse, which means this side is 10 meters a second in the horizontal direction. And then the vertical direction would then be 10 root 3 meters a second because it is x root 3, and then 2x for the special triangle. So now that we know that, we have to split the horizontal and vertical vectors into two. So we're going to have the vertical first. So if the object is going up at 10 root 3 meters a second, then it'll be in the air for 10 root 3 over 5. And that's just a shortcut for finding how long it'll stay in the air due to gravity, which means it'll be in the air for 2 root 3 seconds, or about 3.46 seconds. Now that we have that, we can go to the horizontal vector, and then we multiply 3.46 seconds times 10 meters a second in the horizontal direction, which would give us 34.6 meters. And now to answer the problem, we know that the field goal is 30 meters away from the kicker, which means this distance is 4.6 meters. So helmet is 4.6 meters away from field goal. And that is our answer for the first part of the problem. Okay. And then for the second part of the problem, we need to find how high above the ground the ball is when it crosses the field goal. So for this one, we're going to need to find, instead of solving time with the vertical direction and then applying it to the horizontal, we're actually going to do the opposite, because we need to find out how long it took for the ball to get to 30 meters, because that's where the ball is when it crosses the field goal. So we do 30 meters divided by 10 meters a second to find time, as that's just rearranging position equals velocity times time, and that'll give us 3 seconds, which makes sense because it's going 10 meters a second horizontally, and it goes for 30 meters. So 3 seconds, it gets to the field goal at 3 seconds. Now what we have to do is go to our vertical vector, and then now we have that our 3 seconds, we need to find the position of the football, and for that we're going to use our 1/2 at squared equation. So we're going to write it as x equals 1/2 times -10 meters per second, which is gravity, and then times time squared, so we have 3 seconds squared, and then we have plus our initial velocity, which is 10 root 3 times 3 seconds, and then plus our initial position, which we don't have any. So that is what our formula is going to be, and this first part will simplify 1/2 times -10, and it's -10 because in this case gravity is going down, and our vertical velocity is going up. So negative 10 times 1/2 is negative 5, and then 3 squared is 9. So 9 times negative 5 would be negative 45. And then we add 30 root 3, because it's 10 root 3 times 3. And if we go to our calculator, 10 times the square root of 3 times 3 would give us 51.96. So we have x equals negative 45 plus 51.96. And now here, if we just subtract 45, then we will see that we have the football was 6.96 meters above the ground. That would be this distance here. 6.96 meters above the ground when it crosses the field goal. So just to recap, in this scenario, we had to use the vertical vector to find the time and then apply that toward the horizontal to find the range. And then here, we had to use the horizontal to find the time, and then we apply that to the vertical to find the position.